begin in 3, 2, 1. Flags have been planted. Your team has owned a user flag. Your team has cloned a machine. Warning, your team is losing availability points. May your experience lead you to victory.
Welcome back, everyone, to another South African Hack the Box meetup. Tonight we're going to be chatting about using Docker for hackers. So I hope you're all ready for it on a cold South African evening. And let's jump directly into it. Just want to double check that I'm not muted again. Great. So the agenda for this evening is a short introduction, this part basically, then a presentation on Docker. Mainly, we're also going to just quickly touch on a tool called Don, or Don, I think it's pronounced. And I'm just also going to show you something called Kboxer that's coming up in Kali Linux quite soon. And then, as always, we're going to be hacking together on the dedicated lab provided by Hack the Box. Just some housekeeping. Please try and ask any questions on YouTube, because I can see those and respond to them by showing them on the screen as well. You can also just chat in Discord if you want, but if you want answers from me, or at least attempts at answers, I'll be checking the Discord one. Please do join Discord, because that's where we have a lot of fun, and the practical session is going to be where we actually attack some of the boxes on Hack the Box and work together with that. And for everyone just beginning on Hack the Box, if you have any questions, if you need any tips, if you're struggling to get Kali set up, or you want to learn about what certifications to do or which boxes to try, just reach out to myself and Toko on Discord, on meetup.com, and we can definitely help you. We're very happy to help. Before we get into it, a very large thing happened in our community recently. A team from HackSouth, made up of BeccaQ, Megalodon, and JFunction, actually won first prize at the GovX Innovation Challenge. And that's quite awesome. I think we're very ecstatic. The whole community is 100% behind them, and very happy for them. Just something else, I want to give a shout out to SOCFEL. It's a locally developed digital forensics and incident response CTF. It's up on socfel.com. So please have a look. It's great fun. It's not time-based. You can take all the time you want, but you sort of need to find clues and solve puzzles and figure out how servers were hacked through actual tools and things you can actually use in professional capacity as well. So it's great training in a gamified way, like Hack the Box. And right, we're here for Docker. So this presentation is going to be on how to use Docker as a hacker. So we're not going to be focusing on blue team or developer aspects of Docker, although those are quite interesting in themselves. But Docker is useful for people attacking and doing red teaming. So we're going to look at that aspects specifically. We're also not going to be attacking Docker really in the presentation part. There is a Docker attack in one of the boxes we're going to be doing in the practical section, but the focus is just going to be on using Docker. And I think let's jump right into it. This slide isn't very self-explanatory, but I'm trying to show that when you install things these days, they bring with them a lot of dependencies. And to be honest, if you stick to your Linux package manager, you'll probably be okay. But the way we do things is we need to use a lot of exploits from different, like written in different languages. Some of them old, some of them new. Some need old libc dependencies or C libraries, and some need Python packages. Some need Rails gems. Some need Perl scripts, and some need things in Python 2, some need things in Python 3, and it might be possible to actually get all of these things working on one machine, but I don't know how, and I don't really have time to become an expert in them. So this is where Docker really shines for me specifically. This is what I'm using it for about 95% of the time. And then sometimes you need to replicate versions of applications running at a client, and those things might be quite old, so it's tricky to find them and install them. But sometimes there's Docker containers for those specific versions, so you can very quickly match the application running in a pentest environment or in a lab on Hack the Box. In Windows, there used to be this thing called DLL Hell, and it's still there. It hasn't really gone away, but that's where you have multiple versions of dependencies, and in one application, you could have some component of it using one version of a DLL, and another area of the application might be using a different version, and then it's quite difficult to actually manage that. Docker specifically helps you a lot with config files and versioning, and we'll be looking at how to actually get that benefit. So there's sort of this joke, like how was Docker born? But it's actually even before Docker, when software became so complex that it sometimes didn't work outside of the developer environment. So developers would build something and it works fine, and then they ship it and it gets deployed to a production environment and then it breaks. So people began thinking, well, why don't we just create the whole virtual machine and ship that? And that's basically what's happening these days. So if you go on Azure, I'm just using Azure as an example, but if you go on Azure Marketplace, you can get Tableau server, and that actually is a BI type of application, but you actually get a whole virtual machine that's optimized and configured for running Tableau server well. And the same for all of these other VMs, and there's tons of these things. And there was a time where companies had these golden images of their applications that they ship the whole virtual machine instead of just an application that people need to install, because the install has become so complex and you need to tweak the virtual machine to work just right with different optimizations for network settings and firewalls and rules and all sorts of things, and that gets very complex. So along came Docker, or not just Docker, there's a few containerized solutions, but Docker is sort of leading the pack right now, and it doesn't look like it's slowing down, but there might be real competitors around in a while. But for now, almost everyone is using Docker. So on the left-hand side, you can see how virtual machines work. So a virtual machine has a whole operating system and libraries, runtimes, and everything, and then the application is packaged inside the virtual machine if you're shipping your apps as virtual machines. On the Docker side, it's a lot smaller though. So you only include the runtime and your application, and you ship that. So application written in Python might include Python, the Python libraries the application needs, and the application itself, and then maybe some configuration files. and that gets run as a container being virtualized. And it's the benefits of doing that is you don't need to be patching the operating system. There's a bit you still need to do if you're on the blue team to make sure those Docker images get updated every now and then, the base image for your application. But it's a lot smaller. So we're talking about hundreds of megabytes instead of multi-gigabytes for these virtual machine images. So top right, John Carmack from id Software recently said, Docker containers are kind of neat. They're also a kind of a craven surrender to the rotting mess of excessive software complexity. And it's true. It's just where we got to with dealing with all these different versions and configurations and things. It's unfortunate, but that's true. So this slide is quite complex. I'm not going to spend too much time on it. It's just to get a abstract picture of what's going on. So in Docker, there's a registry somewhere in the cloud usually, but you can have your own private registry. One of the machines we're going to be looking at tonight actually has a private registry that we need to compromise. But the registry is where people upload Docker images. And companies can have private ones in the cloud or on-prem, but the biggest one is called Docker Hub, and I'll show you that in a minute. And that's where you get your Docker images. So the Docker images are sort of the package that you use to create a Docker container, and the Docker container is the actual thing that runs with the application in it. So the image is sort of what the container needs to spin up, and you get the containers in a registry. Or you can actually make your own your own image. We'll chat about that as well. Okay, right. I'm not one for excessive slides, so we're going to be doing a live demo. So just to explain, what we're going to be looking at is different types of applications run in different modes, right? So you might have an application that you run and it does a thing and it gives you an answer and then it's done. And then sometimes you've got an app that you launch it, but you're going to be using it for a while. So this might be the Python interpreter or Metasploit framework where you're doing things. So it's interactive applications. And then you've got services. So this could be a website that's running. So you're launching an application, but you're going away from that window and going into a browser or into some other service like a database client or something to actually interact with it. And then we're also going to look at providing resources from the host to the actual containers. So most of the time, I use only these two, and it's for getting files from the host into the Docker container that's actually running, and also exposing a Docker container on the network. So if I want to do a reverse shell, or if I want to host an application that people outside my machine can connect to through my machine into the container, that's what you would do with network binding. There's other things you can expose, but this is what I'm using almost exclusively. I don't think I've ever actually used some of the other things you can expose. So let me see. I'm just going to clear this folder. I just want to see if I can increase the size quickly. It's Control plus. Why didn't that? There we go. So the first thing you need to do is actually install Docker. I asked Nicholas to share this sort of reference sheet. I don't want to say it's a cheat sheet because we're not cheating on how to install Docker. There's two ways basically in Ubuntu and Kali. The first one is what I usually do. This gets the latest version of Docker Community Edition. And then there's a second option that you can do, where it uses the one in your Linux package manager, and this one is usually slightly older, but that's fine too, unless you really know you need some of the latest features. So I'm not going to go through the installation, but once you've installed it, you should be able to call things like Docker container list, and this should return. If you're getting access denied, it means your user isn't in the Docker group, so you might need to do a sudo. And in my notes, I actually mentioned you can add your user to the Docker group like this, but you should be careful when doing this because you can abuse it to get root access. I'm not sure if that's something they fixed or might fix, but Relix is saying, am I still using apt-get? This was from the actual Docker from their site. So I just use apt. So yeah, this adding your user into the Docker group can be abused to get root access, but if you're using Kali, it's most of the time it's sort of a throwaway VM, so that's what I'm doing. So I can just call Docker without actually doing anything to, without sudo, sorry, train of thought. So the first thing you want to do is actually get a Docker container. So you'll use the command docker image. Sorry, you'll use docker pull, but now you need to get a image name. So the place to find images is on Docker Hub. If I can type. So Docker Hub, it's just hub.docker.com. When you say Docker pull, this is the default place it pulls from, and you can find tons and tons and tons of images here. You can find official ones and verified ones. So these ones are sort of verified safe. Someone has reviewed them and they verified the publisher is the actual company behind it. And the official images are usually pretty trustworthy. Although it's fairly tricky, I think. I'm not 100% sure about this, but I think it's fairly tricky to exploit a machine from a Docker container unless you give it access to certain things on the host, unless there's a vulnerability as well. So if you use verified and official containers, you should be fine. I should say images. I keep on mixing up the two. So they also say this is how you actually get the image. So I can just say Docker pull Ubuntu, and you can also specify a tag. So you can say Docker pull Ubuntu : and then one of these tags. If you don't specify one, you're always going to get latest, and you can see latest at this point of time is focal, which is 2004. So let's go ahead and do that. So say Docker Ubuntu, if I can type, and I'll, instead of not specifying anything, I'll just say I want focal. So that should get the image to your Docker images, and now I can actually see that if you go Docker image list, you should see it there. But this is not just an image, it's not a container. So if I say Docker container, Docker container list, there's nothing there. So the next thing we need to do is say Docker run Ubuntu and focal. So this is going to run, the run command is going to turn your image into a container that's actually running. The thing, so something else I needed to mention is if you haven't done a pull, this will actually automatically pull it for you. So you don't really have to do the pull to get the image. You can actually just go directly to run. And if I run it, you'll see it does nothing, which is weird. But if I now say Docker container list with an A at the end, it's going to show it there. So this A basically says, show me all the exited containers as well, not just the running containers. Now, the reason why this run didn't do anything is because when you run this Ubuntu image or container, it actually runs bin bash, but there's no interactive shell being created, so it actually just dies. So the way you can make it interactive is with the -i, and to create a TTY, you create you do -t. I usually just combine the two, so I just do it like this. So now it's actually running. So the Docker container is running, and I'm actually inside the container at the moment. So you can see I'm root over there, but I'm still outside. I'm still spy. And if I now say Docker container list, and let's say all again, you'll see there's two. One of them is running, so it's up for 19 seconds, and the other one is exited. If I don't do the A, I'll just see the one that's actually running. And if I just quit and go back and say list, nothing is there. But if I say A, now there's two. So this just running containers actually creates a container, and they keep on sort of building up and building up and building up, and that's not really what I want. So there's a way to say auto remove the container once it exits. So when I do --rm, this will actually auto remove it once I'm done. And so let's say I'm doing things in here, and then I exit, and there should still be only two if I now do the list, and you can see there's still only two. So it actually auto deleted the first one. So this is in a nutshell how you actually run interactive Docker containers. You do a -it and then --rm. You can also give it a name if you want. So you could see all of these I was running earlier actually had a name that was auto-generated. So the first one had a name called ecstatic Bernal, and the second one was busy. Was it busy Panini? Yeah, looks like it. So these names get auto-generated because I didn't specify one, but if you are going to be keeping them around for a while, you can give them names like bin bash, and then you should see that when you list it, you can see there's my running container, and it's called bin bash, and it should again auto delete. To get rid of all of these containers that are now lying around, you can just do Docker container. So I usually do a prune just because it deletes everything, but you can do rm and then specify the container ID or name. You don't even need to specify the whole ID, so you can use the first characters as long as it's unique. So in this case, there's only 353 and 1 dB. So if I just say 3, it's going to identify that one uniquely, and then it's going to delete it. But I like to do Docker container prune, and this actually deletes all the stopped containers. So I just say yes. You can also do it with a -f to just not ask any questions, just delete all of them. And you can see what's interesting is total reclaimed space 0 bytes. And that's because I didn't actually add anything in that container. It was just using the image with no additional overhead, no log files, no files added into it. Yeah, thanks, Toko. Don't make fun of my typing. So it's there's actually no overhead in containers if you're not actually adding files into them. They're just using the image as a base and then doing yeah. So the container layer that's being added is there's no space taken up by that at all. So I want to show you how to actually run a service. So if you run a web application, you want to run something that's going to be running in the background, and the way you do it is with a -d. So that's going to cause it to detach and just run in the background. But this Ubuntu one is not a good example for that because it's going to try and run bin bash, and that's not really useful. So we would like to get something else. Let me see what I used before. Yeah, GitLab is fine. I can use GitLab. Let's actually use GitLab 3 as the name as well. That's fine. So I'm also going to say auto, well, let's not auto remove it. So this is going to run GitLab, and it's going to be running as a local container. Just needs to download all of that. I'm running this in the cloud, by the way, so my download speed is quite decent. At least I thought it was. Why? So it's said it downloaded it. I think it's trying to spin it up right now. I'm pretty sure I said run. Yeah, docker run. Yeah. Okay, there we go. So the last command or the last output you'll see is actually this hash, which is the whole hash for the container. So that's this is just the short name, and you can see it's exposed on these ports, but it's not exposed on those ports on my local host. It's only exposed on those ports in the container itself. So to actually interact with this, I need to use a web browser on those ports on the Docker container, and I don't know the IP. I think you can probably get it from the outside, but I usually just say docker execute. So docker execute is going to run something in an existing container. So we know this container is running. I'm just going to say 60 as the unique identifier. I can also use GitLab 3. And then I want to run bin bash. And hopefully I can see the IP. It's not there. Let me just guess it. So another thing to note is on your machine, you'll see there's a new network interface added called Docker. So this is for the Docker network, and the Docker images in this, or the Docker containers that you launch will be running in, I just want to check if I can get it this way. No, it's not there. But I'm not going to install network tools now. But so the Docker images will be in this IP range, and I think it should be the first one. Yeah, there we go. So if I just say call, so I can now actually let me open this in a browser. This should work, unless I did something horribly wrong. Foxy proxy is off. I don't know. But the way to actually run these things is to bind it to your own network or to your own host. So I'm going to do that now. Docker. Let's say just Docker stop. I think it's GitLab 3. And it should be auto-deleting. Let's say I'm just going to delete that one, and then say docker run GitLab 3. So what you want to do is actually expose the ports from this container as ports on your local machine. So the way you do it is with P, and that's shorthand for expose. You can also type it out like expose, but I'm just going to say I want to expose 80 as, well, let's say my local host 8080 as 80, and let's do 8443 as what that machine actually exposes on port 443. So this is going to expose my localhost ports, these specific ports, and it's going to bind them to the ports on the actually running on the container. So this is useful for when you want to do like a reverse shell, or you want to give access to a machine you're attacking. So if you may be running responder in a Docker container, you'll want to expose a bunch of ports for responder to be able to see or get incoming requests for all sorts of things. So that's now running, and I should now be able to actually say HTTP localhost, and that's, no wait, sorry, it should be 8080. I think let me try 8443. I think it's working, but it might still be launching. Let's have a look. Container list. Yeah, it says health starting. I think that's probably why it didn't work earlier as well. Let's see if call works. No, that doesn't work. And if I do HTTP localhost, I keep forgetting, it should be 8080. So I think that's listening, but it's not there yet. And I think this just takes a while to actually spin up, because this is running a whole GitLab instance. So there's a bunch of things that it actually needs to spin up before it becomes available. I'll just give it a few more seconds. You can see this container actually also exposes port 22, but I didn't bind that. And you can see the way I bound it binds all the network interfaces on my machine for ports 8080 to port 80. And it's doing it for IPv4 and IPv6. And the same for the HTTPS port. So another way you can actually run this, if you only want TCP on IPv4, you just say TCP over there. And if you only want to expose it on a specific interface, say you're on Hack the Box, you might go 14.10. Whatever your IP is. And I think it's like that. So this will only expose it on that specific network interface. This thing should be done by now. It still says starting, and I can probably see it if I do a top. So what's interesting as well is you can see bundle running, and this is actually running inside the Docker container. So you're not just seeing Docker using a lot of CPU, you're actually seeing Ruby and bundle. And I don't have Ruby and bundle on my machine. This is actually the processes from the Docker container showing up in my host's top command. It looks like it's okay. There we go. So it's not just saying healthy starting, it's saying it's healthy, which probably means it's launched. So let's try this again. For some reason that doesn't like me at all. I think my browser might be configured to go through another proxy or something. let's see, call. So call works. It does a redirect to this user sign in. Yeah, I see Relix is asking no Ruby, RIP, WP scanner. So this is a brand new Kali box. I don't think I have WP scan on here. So you can see the actual website is working. I'm not sure why it's not loading through my browser. I'm not going to try and debug that right now. So that's how you run a Docker service, basically like a web process. So it's still running container list. And the other thing you can do with containers is you can start them, stop them. So if you didn't run it with that RM command, you can stop them and they'll stick around and you can restart them. So this is useful for long-running containers where you want to make some config changes and you have to restart them, or you want to keep on using them later. So I'm just going to stop this one and I'll just use 3. I typically like to use the first digit or 2 and not the whole name because it's just faster to write. And let's just kill all of them. Docker containers, container prune, and just delete all the running containers or containers that have been stopped. Sorry. So now you can see there's actually a megabyte saved by deleting this container, and that's just because GitLab does some initialization and setup and log files and things, so that actually adds some overhead over just having the image. So images, let's just have a look what's going on in my images right now. Image, there you go. So you can see GitLab is quite bulky. It's like 1.9 gigabytes. There's a lot in there. Ubuntu is actually quite small. One of the smallest ones you can actually get is called, and now I forgot the name, but it's called Alpine Linux. Yeah, that's it. So Alpine Linux is used for a lot of small, like base images, and it's only 5 megabytes. So you'll want to, usually as a blue team person picking containers as a base for something, Alpine is a good choice because there's not a lot of living of the land binaries and things in there. So it's very small, and then you can just add the libraries you need for your app, and then yeah, keep things simple. I just want to remember if there was anything else I wanted to show on this. So we did folder mounts, network binding, interactive applications. I think that's it. So let's continue. So we're going to chat about making custom images. So it's super easy. I'll show you how to do it. And this could be useful if you want to make an image for pen testing. So if you want to have an image that you take on engagements or use for tools that often break your environment. So I spoke to someone who recently tried to get the Eternal Blue exploit working from Python 2 in Python 3, and that was quite a mission. They ended up rewriting it, but you could have just used a Python 2 base image and then added the Eternal Blue stuff and then used that. So you might have seen when I pulled these Docker images that they downloaded a bunch of different things, and those are called layers. So I can have a look at, say, Docker image. I think describe is the right word if I can type describe. Let's say Ubuntu. I don't think it's describe. The one I'm looking for is called history. There's also inspect, but history is usually quite interesting. And I'll just say Ubuntu. and I have focal on here, so not latest, focal, like that. So you can see this is actually what that container is made up of, or the image is made up of. I keep on mixing the two, but there's some initial files, and then they ran this command, and then they added that, and then they said make directory and did some additional things. I think you can say no truncate, no trunk. Oh, there you go. So then you can see the whole thing, but it's actually, because I'm zoomed in, it's not good. And then at the end, they said, well, when this launches, we want to run bin bash. So all of these things are layers that were added. So to create a Docker image, you create a file called Docker file usually, just like that. And the first thing you do is you say from, and then you pick a base image. Now for our use case, this isn't that important. You can use Ubuntu, which is nice. You can use Parrot. So Parrot actually has a base image. It's quite a bit larger. It comes with some hacking tools and things. But let's keep on using Ubuntu Focal because we've already got that. And that's sort of a minimal image file. And how you now turn that into an image, you say docker build and current directory. That's minimal. You can also just give it a name. So I'll just say tag hack the box meetup, whatever. And it made an image called hack the box meetup latest. And if I say docker image list all, you'll see there's hack the box meetup. But you'll also notice that my Ubuntu Focal image disappeared. No, it's actually still here. Okay, let me try something else. So what I did previously is I noticed that if I do just the build and I don't specify a name, and I do that, it only shows the Ubuntu Focal one, because these two are exactly identical. They're the same thing. They just have two different names. So if I create a unnamed one, it doesn't actually create a new one. It says you've already got this. If I create a named one, it looks like it actually creates a second image, but I suspect it's going to be sharing the same base, so my image probably doesn't take that much space on my disk. I'm not entirely sure about that, but I can investigate that later. So there's a base image, but now to make that useful, we actually want to maybe run some commands, and let's do like apt update. We want to do apt install. What do we want to install? Maybe Vim, maybe Z shell, maybe Python3, and so on. And we want to say when, well, let's say actually we want to expose a port, so we can expose ports through this. So this is going to be a attacking container with some remote shells and things. Let's use the over 9,000 range. So for reverse shells, you might want to have a few ports open for if you need to do all sorts of funny things, and not only have one reverse thing coming in, but you might want to host a web server to get the payload and some tools to get some binaries, and you want to have a reverse shell, and you might want to reflect. So I usually have quite a few of these open. And then if we don't add anything else, it's going to keep on using the bin bash from Ubuntu Focal as the initial exe to run. But let's not do that. Let's say we want to use Z shell, and I think it's going to be in user bin Z shell. What you'll see when you look at some of how people make these files is they try and only do one run, because each of these things is going to add an additional layer. And there's sort of this drive to keep things tiny and have very tiny images at the end of the day, especially if you are going to be publishing them, then that's a good idea. But if you're just making them for yourself, it doesn't really matter. So let's actually build this one now. Let's say build, and I'm going to say I want to tag it. So you can see now it's actually getting all of those things and installing it. It takes a while. And there's all sorts of cloud pipelines you can actually use to create these, to automatically build them on GitHub or GitLab, and then see all of it. So now I've got my Hack the Box Meetup, and you can see it's 199 megabytes. And you can see there's two intermediate ones because I did a so it's going to show the intermediate images as well. So this is basically the Ubuntu focal, and then I ran apt install a bunch of stuff, so it made it bigger. And then I ran expose ports, and that doesn't actually add any size, but it changes the image ID or the checksum. So that's what happens. And then I added the change to the command, which runs when I run the container, and that made another one as well. So it doesn't add any space, but that's why there's actually three. So now I can go docker run, and I want to run this interactively. I want to delete it when it's done, and that one, and let's give it a name as well. Let's just say name hack the box. I usually don't name things because I just delete them when I'm done. And then we should be launching Z shell. So this should now be Z shell running. I actually don't even know how you check that, but there should be it should be running Z shell now instead of then bash, and there should be a Python 3 on here. And what else did I install? I think maybe Vim. Or maybe not. Oh, I did. Yeah. So that's how you create custom Docker containers. A few people tend to go overboard. So I wouldn't create a Docker container that's replacing my Kali Linux, because then you're going to be running into the same issues where you've got all your tools in an image, and you might run into versioning issues between different things like Python 2 and Python 3 and Ruby and all sorts of additional things. So I tend to create like a container per tool or an image per tool. Or most of the time, I'm actually not even creating my own images. I'm just using things from Docker Hub. So yeah, that's layers and custom images. Any questions? I'm just going to check on YouTube if there's any questions. So there's a question from Quincy saying, are Docker images used in full production, or are they used for DevOps, DevSecOps people on a tiny workstation as they build a solution? So the answer is both. So if you use Docker in prod, we're more talking blue team stuff. So then you want to make sure you're actually not running the application in Docker as root. You want to try and make the the file system read only. There's all sorts of things you can limit permissions and really harden your containers. It's then also quite important to pick base containers, there's a company called Sneak. Let me actually go to their website. They're actually very good at this. If you want to look at securing Docker containers for production, so they've got tools where you can query base containers, and they'll say if there's any issues with that base container, like known issues, and then you can remove living of the land stuff, and they can analyze your Docker deployment things. So if you're deploying into Kubernetes, they do analysis of that to say, are you sufficiently locking down your containers when you're pushing them out and hosting them? But yeah, software developers even sometimes use Docker during processes just to test things locally. But the whole reason why people are using Docker these days is to actually ship the application as it is in dev on production environments. So a good question. I'm just not like, I've done quite a lot of investigation into that, but this is not really that talk. Can I speak from experience? Would you rather use something like Kubernetes Engine or Rancher? I don't know. I haven't used either of those. I have used Azure Kubernetes Service. I have read about Rancher, but I can't really comment. Maybe someone else on Discord has an opinion on that. There's a Docker Enterprise container platform which is geared towards hosting clustered workloads. Yeah, there's quite a few different ways to host these in prod. I'm not an expert, but Kubernetes is a big one. There's Docker Swarm, which is by the Docker company, and there's quite a few different ones actually. I looked at a few of them, and you can do all sorts of crazy stuff. Relix said ifconfig. No, so these Docker containers are typically very scaled down, so you don't get the tools you want. If you want them, you need to install them. So that's what happens if you use Alpine Linux or Ubuntu as a base. But if you use the Parrot container from the guys who build Parrot Linux, you'll get a lot of tools and things, and I'm sure they'll have IP and ifconfig in there. So when pruning, do you lose data generated within the instance, like log files, things running in the container? Yes, you'll basically lose everything. So if the container is switched off and you prune your shutdown containers, you'll lose everything. I forgot to show you the mounted stuff. So let me jump back to that quickly. So let me quickly show you. So like we did with Docker. Now Toko is going to make fun of me again. But like we did the port stuff, you can also bind the local file system. So if you're not actually mounting the local file system, it's going to own the Docker container. Is only going to have access to things inside that container. So when you want to do things like editing files or using passwords and feeding password lists to crack map exec or anything like that, you actually want to mount local file system as well. So I'm just going to say auto remove, and I want to run Ubuntu Focal again. And the way you do that is you just say v, and then you mount the local folder you want. So this could be whatever local folder you want, let's say root, and you mount that to root in the actual container. I'm not going to do this. What I usually do is this. I say the current directory, because if you say that, it actually takes the current directory. So instead of remembering where I am, I just say pwd, and then I mount that to somewhere, maybe whatever. It doesn't really matter. You could do it app, or so the file system inside the container is not that sacrosanct, so you can sort of do whatever you want. So if you go to here, you'll see there's a folder called whatever, and in there you should see the Docker file that's on the host operating system. If I now actually write something here, come on, okay, this is bash, into a test file, and I go back to my folder, oops, into whatever, obviously, and I go back here, you'll see it actually created it on my host as well. So this is useful for when you want to pass files into the container for using, and also if you want to persist anything you do in the container. So if you've got a database service like MySQL running in a container, you'll typically actually have the actual database on the host. So if the container dies, you can just spin up a new one with the database file. And yeah, there's that's quite a common use case to actually save files locally. But you can see I'm running this container as root, and when you're doing blue team stuff, you actually don't want to do that. You want to make sure your prod. So there's actually a thing you can actually at the end, once all of these things have run and installed everything, you can say user, and then the actual, I think it's the user ID to use, but you might want to do a run and then first add the user and add the user to a group to just lock down your Docker containers. Okay, sorry, I missed that earlier, but now we've done it. We're going to quickly have a look at something called Don, or I think it's pronounced Don because it's Docker for pwning, I think. And this was created by Leon from SensePost. He's on Discord as well. So it's a Docker pwning attack tool manager. So this is just to make it easy to run certain pen testing tools through Docker without having to get as deep into Docker as we did. But I think it's always useful to understand your tools. So the way to install it is you go pip install, if I can type, like that. I've already done it, so mine's quite quick. And then you can say, well, you can just run it, and it will show you all sorts of things. It will check your environment. It's saying I don't have a local network for it, but it should auto-create that. So I'm just going to say plans and show. So you can see all the different plans that are built in. And let's actually just have a look at one of these, because it's basically what we've done so far. So you can see the plans just have a name. It says this is the name of the image to create. And then there's a built-in Docker file. So you can see it's using Golang, the Alpine version, so it's tiny. And then it's doing APK. It's doing all the things to make the resulting image very small, so no cache, doing all the things in one single run command, so there's only one layer being added. It's setting an environment path or environment variable called path. It's changing the work directory, so we haven't spoken about that, but it's basically saying when this F5 launches, that's the current working directory. So it's going to be launching there. And this is the default mount. And it's going to mount to a folder called data. I think this is how it works. And it's also going to say this shouldn't be run in detached mode, but it's also not interactive. So it's going to run, give a lot of output, and then exit. But you'll see, so you can create your own plans, and then you can just run one of them. So I'll just say Docker plan, or let's say just run Metasploit. And this is what I mentioned earlier when I did the check. It said my network doesn't exist, so it's creating it. And while that's running, let's actually have a look at this plan. So not much in here. You can see it's going to expose one port. I would typically expose a few because Metasploit sometimes has needs a few, so I would probably add a few more ports in here. And it's saying it needs a TTY, so it's interactive, and it's actually just grabbing the official Metasploit framework image, so there's no custom compiling and things happening in here, which is nice. Almost done. There we go. So you see it just boots me back to the to my shell, but it says how to attach. You say docker attach, and that's the name it gave it, so you can just do that. And then if you want to detach, you do Control P and then Control Q. So if I do that, now I'm in Metasploit framework inside the Docker container. So if I say Docker container list, I should be able to see it here. So there's my Metasploit. Well, one of them is my local network this toolset creates, and then my second one is the actual framework, but I'm not in Metasploit, so I can search for exploits. Terminal, come on. Terminal blue. There you go. And then I can use them as normal. And my container can speak to the outside network, and then if I listen on my host IP, so I can do netstat l np, let's do sudo on that to actually see the running application. And I think this is on quad 4. So you can see Docker is actually listening on my host machine on all interfaces for any incoming stuff. So this is to catch any reverse proxies or reverse shells coming in. And that's in a nutshell this tool. It's quite useful if you want to build up a list of plans to handle all of your red team tools and things. It will all show up in this menu, so you can use any of these that are built in, and you can very easily create your own. So just have a look. It's definitely worth checking out. If you don't want to learn all the different Docker commands, you can sort of so you'll need to learn Docker anyway, but you don't need to remember all of it. So you can build your plans and then just execute those as you actually need them during engagements and CTFs. So that's done. And then lastly, before we jump into the labs, K-Boxer is something that's been mentioned by the Kali people. They're talking about how they are struggling as the Kali package maintainers. They are struggling to get all the applications running in Kali. So what they came up with is a way to basically package applications in Docker containers with some metadata so that you can ship them for Kali. And this will work for basically any application. It's quite cool. So I didn't know it, but you can actually run UI applications like Firefox through Docker, you just need to expose the host X11, which is the windowing manager, the socket to the Docker container, and then it can actually push application screens and things into your host. So it's quite cool. Then web applications need to have HTTP like we did previously. So they've already got a few examples out. So you can right now install some of these tools actually running in KBox or KBox. I'm not sure how to pronounce it. But it's still in preview, but they are inviting developers to actually begin packaging their applications. You can create desktop links and everything so that when people install these packages in Kali, it's going to have desktop icons and everything. So I think this is pretty cool. It's a challenge that they're facing that's probably slightly different than some of the other distros that are not so focused on exploitation tools, because a lot of these tools don't get updated. There's a bunch of legacy tools in older versions of Python that need older versions of Python, or someone needs to basically go and rewrite it. But it's a bit of a mission. So this looks quite cool, quite good. And that's it. That's the whole presentation. So now we're going to jump into the labs. So there's two machines we've got tonight. One is called Laboratory, which is slated as an easy box. I didn't finish creating my notes, but you need to use Docker here. Well, you can do it without Docker, but I suggest using Docker to create a GitLab instance. So it's very similar to what I explained here. You can actually use this directly, but you'll need this in part of the initial exploit. You'll need a local GitLab instance, and then you'll need to set the actual key. I think it's called secret key or something inside your Docker container. So you need to run it, and then you need to basically do this, like execute interactively bin bash to get a shell in the container, and then update the key. You need to stop it. You need to start it again to load that key, and then on the second time when you go in, you can actually create a serialized exploit using the GitLab CLI, and then you can run that against the target, and it should let you get a shell. The second one is quite difficult. This is actually exploiting things in Docker, but I thought it might be interesting because you will be able to get access to a private Docker registry, and you'll need to use the Docker REST API to actually get some information about images and things. And then finally, you'll be able to find some secrets in the actual Docker image. And so there's that Docker history command I showed on the image. You'll need to use that. And you'll also need to actually spin up the container and look around inside and find some things as well. So without further ado, I think we're going to take, let's say, a 10-minute break and then meet back 25 past 7 to do some hacking in the dedicated labs. Right, I'm going to end the broadcast and join you guys in Discord. See you there.